Welcome back to True North Mechatronics. In this episode, we're modeling the caster housing for the ball bearing caster that sits under the chassis at the back of the robot. To set our ride height, we're also designing a custom chassis pitch spacer. This spacer sits internally on top of the caster, forcing it down to the bottom of the housing, and it constrains its z-axis travel and locks the robot so that it's perfectly level with its ground that it's traveling on. So design, engineer, deploy. Let's get to the CAD. Let's begin by creating a new body and a new sketch on the XY plane. Grab the rectangle tool, and we're going to create a rectangle that is symmetric around the origin. We'll do that by clicking the top left-hand corner, the bottom right-hand corner, clicking on the origin, and clicking on the constrain symmetric tool. Let's set the horizontal length of our caster housing to 21 millimeters. And its vertical length to 27 millimeters. We're going to include 4 mounting holes. This will attach the caster housing to the bottom of our chassis. Let's make it so that these holes are symmetric around the x-axis. And we'll also make it so that these holes are symmetric around the y-axis. Now that we've done that, we can set the center to center distance of the top holes to 13.5 millimeters, which also sets the bottom. And let's set the center to center vertical distance to 19.5 millimeters. Now we need to set the diameter of all 4 of these holes so that they are the same. And specifically, we're going to set the diameter to the minor diameter of the PT screws that we're using for assembling this robot. So that is the base shape of the caster housing complete and fully constrained. So we're going to close out of this, and we're going to pad this shape out to 13 millimeters. Now we're going to create a pocket that goes all the way through this that will support the caster. So click on the top and create a new sketch. And we're going to create a circle here that's coincident with the origin. Let's set the diameter of this circle to 16.2 millimeters. And since we're fully constrained, we can close out of this sketch. And we're going to pocket this all the way through. And so it's 13 millimeters thick, so our pocket needs to be 13 millimeters. Next, we need to accommodate the flanges that are on either side of the caster. These flanges allow for a top to be screwed onto the caster. And so we need to make sure we accommodate that in our housing. We're going to do that by using the slot tool. So place it over the y-axis. Left click again on the y-axis and drag it out. Now we're going to right click to clear our tool, and there's a problem with FreeCAD where we can't just constrain the slot. We actually have to move the slot first. So left click on the side and drag it out, nothing will happen. Left click and drag again. When the slot moves, the problem with the over constraint that FreeCAD seems to add to the slot is fixed. So make sure you do that. Now we're going to reference the pocket that we created earlier. And we're going to make it so that the center of the arcs on either side of our slot are coincident with the edge of that pocket. So we'll do that for the top and bottom. And the last thing that we need to do to this slot is we need to set the radius of these arcs. So let's set that to 3.2. And this measurement comes from just measuring the physical size of the caster that we're using. All right, so we are fully constrained, so we can close out of this now. And we're going to pocket this to a depth of 11.2 millimeters, so almost all the way through, but not quite. Before we move on to the pitch spacer, we're going to add some cosmetic fillets to the edge of our housing here. I'm just holding down Control and left clicking on each side. And we will give it a fillet of 6 millimeters. Gives that a nice round profile there. Okay, so now we're ready to create that pitch spacer. But we're going to do this as a separate body because we want to be able to 3D print them as separate objects. So let's create a new body. But we're not going to create a new sketch. Instead, what we're going to do is we're going to left click on the top face of our caster housing here, and we're going to use a shape binder to capture that shape. So let's rename our bodies that we have here. So let's call this one our caster housing. And this new one that we created, this is going to be our pitch spacer. And we're going to hide the caster housing for right now. And now we're going to left click on the shape binder, and we're going to add a sketch to the shape binder. When we do that, now we can use our external geometry reference tool, and we can pull in the two arcs from our slot. We're not going to pull in the edge of the pocket though, because we are not going to be coincident with it. So let's create a new circle, and let's set the radius of this circle to 16. You'll recall that the pocket is 16.2 millimeters, so this means that we won't have a friction fit with this spacer on the inside of our housing, and that's a good thing in case we want to pull that caster back out again. Now let's grab our circle tool. We're going to create circles that are coincident with the center of those arcs and that terminate or are tangent with those arcs themselves. So let's do that on both sides. And now we have overlapping shapes, and we're going to use the snipping tool to fix that problem. Now we are ultimately trying to accommodate the screws that hold the top of the caster onto the main body of the caster. So we've got screws on the caster that need to sit into these areas right here. So our spacer can't sit on top of the screws. So we're going to use the snipping tool, and we are going to snip away the top part of this circle for the pocket. Then we're going to snip away the top part of that arc, and that leaves us with these two little edges here. So let's snip away the edge here and snip away the edge there. Now, you'll recall that the arcs were constrained to 3.2 millimeters. So let's set the radius on this arc to 3.2 millimeters, and that will constrain that there. Let's grab our snipping tool and let's go back in. We're going to repeat that same set of operations. So we're going to remove that section here. Wrong tool, there we are. We're going to remove that section of the pocket. We'll remove this part of the arc, and then we are going to remove these two little tail sections here. And you'll notice that we have these red coincident constraints there that let us know that the line segment is fully closed. If they were white, you would have to go in and close them. And we are also going to constrain the radius of this arc here also to 3.2 millimeters. And with that, we have completed the external shape of the spacer that we're going to use. If we'd like to see what that shape looks like, we can come back into the model tab, go over here to the binder, and we can hide the binder. And so you can see there's our shape for that spacer. Back over to the task tab, we are fully constrained, so we can close out of that. Again, I'm going to hide that binder, and I'm going to bring back the caster housing so that you can see where that spacer is going to sit. Now, we are going to pad this out, so I'm going to left click on the spacer, left click on the sketch there, make sure that it's green. And now when I click on the pad tool, you'll notice that the pad wants to extend upwards and away from the inside of the caster housing, which isn't really a problem. Once we 3D print this, we can just push it into the caster housing. But FreeCAD does allow us to reverse the direction of our pad, so we're going to take advantage of that. Let's set the thickness of this pad to 2.8 millimeters. And what I meant to do was we're also going to reverse this pad. So when we reverse it, the pad goes in the other direction and extends inwards into the inside of the housing. So there we are. And with that, we have fully completed the caster housing and the chassis pitch spacer. In the next video, we're moving on to the battery box. We will be designing the mirrored left and right sides of this box, and it will anchor directly to the accessory deck, and it will also mount to the top of our vertical frame rail. We'll be carrying over our triangular truss patterns, and we will be engineering a robust tab and socket assembly system to capture the top and bottom of the battery box. Chart your course, build your world. See you in the next one.